Today's topic is inverse of a mapping. Okay. So you have given a function f from a to b where a and b are non-empty sets. You have to check that the function f is invertible. So first you would check that the function is 1 to 1 and next on to. That means you have to check that f is a bijective mapping. Then there exists a mapping G, or called it f inverse from B to A. That means switch on this one, B to A, from B to A. Okay, and that mapping is called the inverse of the mapping f. Now if we write fx equals to y, if the mapping is f, then for the f inverse we have to write x equals to f inverse of y. Sure. Now see the definition. Let a and b be two non-empty sets and f from a to b be a 1 to 1 and on to mapping. That means bijective mapping. Then a mapping G from B to A which associates each element y of B to a unique element x of A such that fx equals to y is called inverse of a mapping f. Sure. Now note 1. The inverse mapping of f is denoted by f inverse. Sure. Number 2. Thus if f from A to B is a 1 to 1 and 1 to mapping, then f inverse is a mapping from B to A, that is f inverse from B to A such that fx equals to y for the mapping f from A to B, and for the mapping f inverse from B to A, f inverse of y equal to x. Number 3. Clearly f from A to B is invertible if it is bijective. Invertible means f inverse exists, same word. Okay. If f is invertible, that means f inverse exists. So the mapping f should be bijective. Now properties of the invertible mapping. Number 1. The inverse of a 1 to 1 onto mapping is unique. Number 2. The inverse of a 1 to 1 onto mapping is also an 1 to 1 onto mapping. That means bijective mapping. The inverse of a 1 to 1 onto mapping. That means if we find the inverse, then f should be bijective. So the inverse should also be bijective. The property 2 says that if f from A to B is bijective, then f inverse from B to A is also bijective. Number 3 point. If f from A to B is 1 to 1 onto mapping, that means bijective mapping, and f inverse from B to A is the inverse of f, then f inverse composed f equal to IA means identity mapping from A to A, and f composed f inverse, that is equal to IB, that means identity mapping from B to B. Sure. Now the problem 1. If f from Q to Q be defined by fx equals to ax plus b, where a comma b comma x belongs to Q, and that means rational number, and a not equal to 0, then show that f is invertible and hence find f inverse. Sure. First of all, you have to show that f inverse exists or f is invertible, same word, and then find the f inverse. Now we have to show that first you have to show that f is invertible. That means you have to check that f is 1 to 1 and on to or not. So first of all 1 to 1. So for 1 to 1 part, we have to consider fx equals to fy, where obviously x comma y belongs to Q because the domain is Q here. So then ax plus b equal to ay plus b, b cancel, a cancel because a not equal to 0. So x equal to y. This shows that f is 1 to 1. Same. So now for the on to part or surjective part, let y belongs to Q. That means codomain of f. See that function is from Q to Q, so the codomain should be Q. So let y belong to Q, codomain of f. Then fx equals to y implies x plus b equal to y. So x equals to y minus b by a. So look at the here, a and b both are belongs to Q in your question given, and y belongs to Q you have to consider. So this part should be belongs to Q, and that should be the domain. So thus, for each element y belong to Q, codomain of f, obviously there exists x belongs to Q domain such that if x equals to, what is the value of x? Y minus b by a. Put it. So a into y minus b by a plus b, a cancel out, y minus b plus a, that means y. And this shows that f is onto, that means surjective. Hence f is a bijective mapping, obviously. And since f is bijective, so if is invertible, that is f inverse exists and is given by x equal to f inverse of y. So now f inverse y equal to obviously x, and what is the value of x? See that value of x is y minus b by a. Put it here. So f inverse y equal to y minus b by a. So thus f inverse from Q to Q, because look at that, f from Q to Q, so f inverse should be Q to Q. If we switch on these two, then this should be Q to Q. So thus f inverse from Q to Q is given by f inverse x equals to x minus b by a for all x belongs to Q. Look at that, here y and y both are the variable, so you change this variable y into x. Got it? So now problem number 2, let f from R to R be defined by if x equals to x cube plus 1, find f inverse x. That means you have to find the f inverse. That means you have to first show that f is invertible or not. That means you have to check that f is 1 to 1. So see this example, same word, let fx equals to fy, and after proceeding you have to got x equals to y, and this shows that f is onto, and for the this shows that function is 1 to 1, and for the onto part, let y belongs to our codomain, if x equals to y, x cube plus 1 equal to y. So x should be y minus 1 whole to the power 1/3 belongs to our obviously domain. Thus for each y belong to our codomain of f, there exists x belongs to our domain of f such that if x equals to, put the value of x, and after simplification we get fx equal to y, obviously, and this shows that f is onto, and hence f is a bijective mapping. So since f is bijective, so f is invertible, that is f inverse exists and is given by x equals to f inverse of y. So f inverse y equals to x, and what is the value of x here? Value of x should be y minus 1 whole to the power 1/3. Put it here. So this should be your f inverse of y. So therefore f inverse from R to R is given by f inverse x equals to x minus 1 whole to the power 1/3 for all x belongs to R. Clear? Now problem number 3. Let a equal to 3, 6, 9, 12, b equal to 1, 2, 3, 4. If f from a to b be defined by fx equal to x by 3, find f and also f inverse as a set of ordered pairs. So now according to the question, fx should be, rule is what, or correspondence is what, fx equal to x by 3. Put it. So now what is your domain? 3, 6, 9, 12. Put it. f3 equal to 3 by 3, 1, f6 2, f9 3, and f12 obviously, f12 equal to 4. So therefore f from a to b as a set of ordered pairs is given by f equal to 3, 1, because f3 equal to 1, that's why f3 comma 1 first element, second element 6 comma 2, third element 9 comma 3, and fourth element 12 comma 4. So that's why I write it f equal to 3, 1, 6 2, 9 3, 12 4. So clearly f is bijective, and you have to check it that this function is clearly injective and surjective. So now since f is bijective, and hence it is invertible, and so if inverse exists, and if inverse is given by f inverse from b to a, and that is, just switch on this one, 1 3, 6 2, 2 6, 9 3, 3 9, 12 4, 4 12. Clear? Thank you so much.